Yeah, perfectly.
So let me share the screen.
Just a second. Okay, you got it. Okay. Can I start recording so everything is okay?
Sure. And let me make it bigger. Okay. So hi everyone. This is for introduce the Spark overall because this is very interesting and popular topic these days. So the content of the talk today is about again I want to repeat what is the big data and what is the Spark cores and Spark SQL and machine learning that we've been looking at. Also, we have Bluemix cloud computing that we have used. So this is, I also mentioned how we have used and what is the Hadoop file system and object storage again, because many of you seems confused. But again, many of you also know exactly what they are. So I was so impressed. So as I mentioned before, there are two cores in big data. So when we take care of a massive or large scale data set, there are two cores. The first one is how we can store the big data, and in Hadoop, the Hadoop distributed file system take care of it. And actually, for cloud computing such as Bluemix and Azure, object storage are used. And at the end, I'm gonna show you the difference between Hadoop file system and object storage. And also, another important core is how to compute or how to process the massive data set. In Hadoop, the MapReduce has been used. Also, its ecosystem, Hive and Pig are running on top of MapReduce. I mean, the Hive and Pig are translated to MapReduce tasks. And these days, because after Spark came out, Spark is actually replacing MapReduce because Spark is 20 or 100 times much faster than MapReduce. Even the coding lines, the number of lines is also like 20 to 100 times much smaller. That's why people are crazy at Spark. So we can define big data as non-expensive frameworks that can store a large-scale data and also can process it much faster than single node. So simply, that is a parallel computers, and parallel computers is actually supercomputers. But the traditional supercomputer is too expensive, but Hadoop is open source, and you can use your commodity servers as the Hadoop cluster. So anyone, any small companies, any small lab or research center, they could build their own Hadoop cluster for parallel computing. And this is kind of a logical diagram how the Hadoop cluster can be built, especially based on Cloudera Hadoop version. Cloudera, one of the most popular leading big data company, has a Hadoop version named Cloud CDH. Simply, we can say Cloudera Hadoop version. And there are like 10 nodes here. The first node is Cloudera Manager that can easily install Hadoop to all 9 nodes in 30 minutes. That is the main point. For Hortonworks, there is a Ambari that is open source to install all Hadoop to many clusters. So this is how it looks like. But one thing you have to remember is for each node, I mean, for each server, it contains Hadoop file system, and it also has a CPU that can process data. So one computer, one server has both file storage, Hadoop file storage plus the MapReduce. And if you add Spark into here, Spark Worker can run on each server as well. So also let's take a look at Hadoop ecosystem again. That runs on Hadoop cluster, as we see in the previous slide. And for data analysis, the Hive-Pig have been popular. Also, Hive-Pig batch processing for more interactive data analysis. The Cloudera presented the Impala, and Hortonworks presented the Tez. Also for data streaming, to process streaming data such as a log file or IoT file, Storm, Flume, and Kafka have been popular. And these days, Kafka and Storm are more popular. And for exchanging data between RDB and Hadoop file system, Scoop has been popular. And for in-memory processing, the Spark is the way to go. So the Spark cores, as you know, now I'm pretty sure most of you know what is Spark, but Spark is actually in-memory data computing. That is a lot faster than Hadoop MapReduce. And the Spark originally came from UC Berkeley AMPLab with the Mesos Resource Manager plus Tachyon file system. However, Hadoop has been dominating the market already. So instead of using its own file system Tachyon or its own resource manager methods, the Spark is simply integrated into Hadoop. And so Spark, that is a computing service, use existing Hadoop distributed file system. Also, it use Hadoop ecosystem such as HBase, NoSQL DB, or Hive. Also, many other cloud computing services such as Microsoft Azure, Amazon AWS, and IBM Bluemix, they have their own object storage that can be integrated. That was actually integrated with the Spark. So instead of using a Hadoop file system, object storage are used for Spark. But the way it works is same as Hadoop file system. To the user, physically they are different, but to the user, the way it is used are exactly the same. So we have a number of Spark cores, such as Spark SQL and Spark Streaming, Machine Learning Library, and GraphX and Spark Owl. And you have experience. You already have experience to use Spark SQL and Machine Learning Library for 4.1 and 4.2. But Spark Streaming and GraphX and Spark Owl is another popular kind of approach, but you may try it by yourself. Some of you, as all of us know, the R is not for massive data set because that is only for single server, single computer to take care of hundreds of megabyte data set. However, there are many approaches to use OWL for parallel computing. One of the examples is Spark OWL. So OWL is integrated into Spark to handle terabyte or petabytes of a massive data set. And it is linearly scalable. So whenever you have more data, you can add more server, more node to Hadoop cluster to use Spark Worker. And if we compare Hive and Spark SQL, because many of you are confused at HiveQL and Spark, so that's why I have this slide. Hive is for data analysis of hardware ecosystem, as I mentioned, developed by Facebook, and it has Hive query language that has a similar syntax of SQL, but HiveQL is still under development, so it has much less syntax than SQL. So HiveQL that runs in Hadoop cluster, but it has a less SQL syntax. That's what you need to remember, because some of you are confused at this. And using Hive, you can turn Hadoop cluster as a data warehouse, and the HiveQL is actually translated to MapReduce jobs. So it is batch processing and it is non-interactive. But as I introduced, BigSQL or the Impala, Tez, they are developed on MPP for interactive SQL processing. And Spark SQL that runs on Spark Executor as part of a Spark API. So you can run regular SQL syntax, or you can even run HiveQL by sharing Hive schema. There is metadata that include Hive tables and each column information, etc. So the Hive and Spark SQL exist each other, but Spark SQL adopt HiveQL to make it run on Spark Worker. So Spark HiveQL is a lot faster than original Hive. That's what you need to remember, because Hive is running on MapReduce tasks, but Spark HiveQL runs on Spark Worker, because some of you are confused at this. So Spark SQL, that is actually to turn on RDD into a relation, like a table relationship. So you can easily use SQL or HiveQL syntax to play with the tables that you create or created by Hive itself. And machine learning library, it provides many machine learning services such as sparse vector support, decision trees, regression, PCA, support vector decision, etc. So if you use a machine learning library, you can predict some pattern, or you can classify or cluster the data set. So let's take a look at how Spark is running on cloud computing. So as you know, Databricks, that is the company who have a number of members from Berkeley AMPLab. So Databricks always lead Spark development. So they have a latest Spark machine learning library. So latest Spark is 1.6.1, I guess. And other companies like Amazon AWS, Microsoft Azure, IBM Bluemix, those cloud computing companies also provide Spark for their own services, but their version is already below behind to Databricks latest Spark version. So, for example, IBM Bluemix, I asked it at 4.2. If you go to if you open IPython notebook, on the top right there is a palette menu. Under there is an environment. If you click on environment, you can see the Spark version. But that is definitely behind the latest Spark version, because Databricks has an advantage to use the latest Spark version. Also, IBM Bluemix, that deploys Hadoop clusters in the cloud. Actually, IBM has its own Hadoop version, so it has a big insight that provide big SQL and big sheets, but unfortunately we didn't have a chance to play with them. Since IBM supports big SQL, they don't have a Hive. They have a kind of there is a way to share Hive metadata with the Big SQL, but it is very complicated. So simply we can say there is no Hive in IBM Bluemix. I mean IBM Big Insights. But it supports Spark because IBM was behind the big data industry. But fortunately, after Spark came out, IBM invested a lot on Spark. So now they try to catch up with the other cloud computing and other vendors such as Cloudera and Hortonworks. So fundamentals of IBM Bluemix is definitely there are many services such as Spark, DB, Twitter analysis. For storage, they have a separate storage called the object storage that you are using that use high-speed network. That is to get over data-intensive computing. The Hadoop is actually data-intensive computing to migrate data to service. I mean, that is actually the service goes to the data. But traditional process-intensive computing is actually to move data to service. But because of a network bottleneck, traditional process-intensive computing. I mean, the traditional supercomputer cannot handle big data efficiently. That's why we have Hadoop and we have cloud computing these days. So as you know, we have assignment 4.1A and B, that is to get familiar with the Spark and IPython notebook, and also the Spark SQL and Parquet, the file format that is popular for performance-wise. And 4.2, I'm pretty sure you are still working on it, but again, 4.2 is simply to use largest regression of Spark machine learning library, and that is to predict if your model can be, I mean, the air conditioner, your heater is working well based on the model and, I mean, based on the system information. So it should be fun if you work on it. Once you finish that, and if you want to learn more, there are sample the Spark machine learning example at the Bluemix, so you may want to try that. And then finally, I want to show you the difference between Hadoop file system and object storage again. As I mentioned, the supercomputer, the traditional parallel computer, is based on process-intensive computing. That is to move data to the computing server. But if you have too big data, then you should have really, I mean, your network always become the bottleneck. So to transfer, for example, 1 terabyte or one petabyte data to the servers, it may take 2 days or 3 days because of the network speed. That's why the traditional supercomputer didn't work for big data. But the Hadoop, like data-intensive computing, is to move computing service to data. So that is good for large-scale data. So let me show you the good picture here. This is Cloudera's this is Cloudera's Cloudera's picture. Let me see what is good for you. Maybe this is good enough. Okay, so actually this is the cluster. there are like 4 nodes, and there's one resource manager for MapReduce and Spark. The resource manager is the master node, and node manager is slave node. And there is actually, and resource manager and node manager are taking care of data processing and data computing. But it is not shown here, but there is another master node called the name node. And also each node has a data node as well. So there's a data node as a slave node, and also there is a master node named name node. They are to take care of data storage. So each node, each computer has both data storage and computing service all together. So once you have a data distributed in these 4 nodes, MapReduce task or Spark worker immediately process the data that exists at the same server. So this is the beauty of data-intensive computing. So once data is there, the computing is occurred. So there is no bottleneck for network speed. So this is Hadoop, or Hadoop, or we call it data-intensive computing. But if you take a look at cloud computing, for example, Azure Object Storage, because IBM Bluemix doesn't provide that much detail about its object storage. But if you take a look at it, then the storage servers and computing servers or computing nodes are separated, and there is a network between these two. It looks like that is the traditional processor-intensive computing. However, the Microsoft provide, and Bluemix as well, Microsoft Azure provides high-speed network named Azure Flat Network. This network is super fast, so it is like storage and computing node are the same node. And you can take a look at this link to if you want to know it much further, you may take a look at this link. So it looks like physically it looks like a traditional supercomputer, but logically, because of a high-speed network, this is working like a data-intensive computing, because data can transfer to computing node in high speed, almost like the same computer. Okay. So Azure provides flat network storage that is also called a Quantum 10 or Q10 network, based on mesh grid network, and it has very, very high bandwidth connectivity. Okay. So this is overall of Spark and the object storage and cloud computing. I guess many of you should have questions. Do you have any question? Any question at this moment? This is a great opportunity for you to ask me any question, because again, there are not many people who know about this. So this is a great chance to ask me this kind of question about Spark or cloud computing and others.
I read here a question in the chat. It says from Romeo. So Spark is an IBM product, but is used by other vendors. That's the question.
No, actually, the Spark is invented by the UC Berkeley AMP Lab, and some of the people there started a new company named Databricks. And then other companies such as IBM adopted that solution to integrate into their own cloud computing, such as Bluemix. For some reason, I cannot see the chatting, like the content.
On the top, to the right hand, you have participant chat. Just click on it and it will expand. On the top right hand.
Yeah, I click on it, but for some reason I cannot see.
Oh, I see. I can tell you. The question was directed to me privately.
Oh, I see. That's right.
So please all send to everyone. Okay. Now you should see. Do you see it now?
Yeah, I can see that.
Okay.
Oh, this is a good question from Rumia. Rumia, actually the point is, Spark can read any data format. So default is text file format, but it can also read the sequence file or the Parquet file. That's why we have an example to read the Parquet file and save it in PowerPoint too. So there is already a library to read or write sequence file in Spark. Thank you. Yeah. Any other questions?
Okay, in the meantime, you're thinking about your question because, yes, we understand it's a lot of information just presented in 30 minutes, overviewing the main component related with Spark. I want to point in another direction regarding, I understand we are at the end of the semester. You have devoted a lot of effort to learning this class, and we are happy you are learning. Just realize that this is for you. Very few universities actually teach some Spark in the classroom at this point. Maybe later this will be more. So the benefits to learn at least something not only theoretical but practical with Spark is very beneficial, and you will realize this later on when you finish your master's degree at UMUC. Just the benefits to be able to put the word in your resume will bump your salary, you will see. So that's why I suggest as much as you can get. The point is not to put something in your resume. The point is to have some knowledge in your belt. So as much as you can, my suggestion is you have this access to Spark and try to do as much as you can. You have instructor here, you have TA, ask question, and go as much as you can in deep. This is the biggest benefits is the practical knowledge you're getting in this class, doing a small project with each of the product we are using to analyze big data, using the machine learning library of Spark or using the big SQL with Hadoop. So this is very important. Another issue I wanted to point, I still don't see, okay. Another issue I wanted to point is the change regarding the cloud environment. As an instructor, we realized that we actually don't allot additional time for get familiar with the cloud. And the cloud is seamless, let's say, but it requires some time to get accustomed to have the services in the cloud, because it's not the same the thing you work in your computer. So of course, this additional time you spend to learn the services in Bluemix, which is the particular cloud environment in which we are working in this class, is going to pay off, because all the company are moving in this direction. If not today, tomorrow, in very near future, your job is going to be exactly in the same way we are doing the practical activity in this class. Everyone is moving to services in the cloud, where you have the data and you have the processing power to work on this data, and everything is there. So I just want to tell, even I understand you feel overwhelmed because it's a lot, but that's the only way to grasp in this very fast-paced technology world as much as possible in a classroom. So I hope, if not today, a little later, you will understand this and you will be grateful. Regarding the change of the version we perceive in the cloud, I can tell you this is plus and minus. Here I just want to elaborate what Professor Wu pointed regarding the last version of Spark. It's very important in production environment to be in the last version, but let's be aware that for an assignment, you do not want change of the version during the time you are developing your assignment. So we have to make sure that this is the real environment in the cloud is change of the version. And if IBM didn't change during this assignment the version of Spark, it has been changing, like the Beacon Sign and other software, and this is very, let's say, proper to the cloud environment and to the service environment. The provider change the version as needed, because this is production environment, and we should understand this regarding the version. So that's our few points. Okay, I see here a comment.
Yeah, in addition to Professor Gorcheva's point, as she said, I'm actually glad that she bring in Spark to you guys. You know, what you guys learned here, actually, in the world, nobody knows it clearly well about Spark and big data. So you are one of the leaders who kind of explore this world. That's why, you know, for example, Bluemix keep changing its environment, because the IT is moving too fast. So even though like it bothers you, you guys did actually great. And again, you are lucky to be with Professor Gorcheva.
Are there questions regarding the assignment, the last assignment, 4.2?
You know, if you go to if you open IPython notebook at Bluemix, you can see two sample the Spark. The first one is for New York taxi New York taxi data analysis. Okay? So that use open data from New York City, and the data set should be stored at IBM Bluemix. So start with that, then you should have a much better idea how you can use Spark and Spark Machine Learning. Thank you, Fred. Any other question?
I guess everyone is all set. Just wishing more time to complete the assignment. And I want to remind you guys that this is the assignment is due this weekend, and next weekend you have to finalize the group project with Watson Analytics. So not much time, no room for more. Of course, you, after the semester is finished, you can go above what we did in this class. And the point is, there is so much information in the community. Just you go to the community related with Bluemix, and you will find, I would say, information about anything you wish. Just you have to allot additional time and continue learning. And I wish with the foundation set in this class, you are all set to go forward. Okay, I don't see more questions. As usually, you know, you post your question, you send your email, and your questions are very fast answered. If there are no more questions, I think we finalize this unless Professor will have something more. I don't have more.
Yeah, that is it for me as well.
Okay, guys, I have recorded this, and I will be posting in the classroom as soon as it appears in the server. And have a wonderful evening, everyone. Bye.
Bye, everyone.